Welcome back to the deep dive. So if you've used generative AI, you've probably seen it, right? The outputs can be, well, incredible sometimes,
Absolutely stunning.
but other times, just complete nonsense, even if it looks good.
Polished nonsense, yeah.
Exactly. So today, we're offering a shortcut. We want to help you move from just hoping for a good result to actually commanding quality outputs.
Yeah, our goal here is really to peel back the curtain, get rid of that magic feeling, and talk about how these language models actually work.
And what's the single biggest takeaway?
Okay, if there's one thing you remember, it's this. Generative AI doesn't understand anything, not like a human does. It's not thinking. It's basically a super sophisticated pattern matching machine, a statistical generator.
That's a really stark way to put it, but probably necessary. Because if we treat it like Google or like a person.
You're setting yourself up for failure.
Yeah, so how should we picture it?
Think of it like a robot locked in a library. A huge library, the entire internet maybe, it's read everything.
Right.
When you ask it something, it doesn't think, I know the answer. Instead, it starts playing this incredibly fast game of predicting the next word, or technically the next token.
Token, we'll get to that.
Right. It just calculates, based on everything it's read, what's the most likely next piece of text. It's all probability. It can't tell if something is true, only if it looks like something it's seen before.
High-stakes guessing, basically.
You could say that.
And understanding that seems fundamental. You mentioned our sources point to three key things determining success or, well, hallucination, the three T's.
Correct. It boils down to, first, the training of the model itself. How good was the data it learned from? Second, the training of the user. That's you. How skilled are you at giving instructions, at crafting prompts?
Okay.
And third, token capacity. There's a limit to how much information it can handle at once. Get those three right, and you really shift the odds in your favor, significantly.
Right. Let's dig into that first part, then the mechanics. If it's not thinking, how does it write something that sounds so coherent, like a business plan or poetry?
This is where the Chinese room idea comes in handy. It's a classic thought experiment.
Explain that.
Imagine someone in a room who doesn't know any Chinese. People outside slide questions written in Chinese under the door.
Okay.
Inside, the person has this enormous rulebook. It doesn't explain meaning. It just says, if you see this symbol combination, write down that symbol combination. They follow the rules meticulously.
And slide out a perfect answer in Chinese.
Exactly. Looks perfect. But the person inside still doesn't understand a word of Chinese or the question.
So the AI is the person in the room, following rules, not understanding.
Precisely. And its rulebook isn't lines of code like if this, then that. It's formed during training billions of connections, numerical weights, based on statistical patterns found in all the text it processed. It learned correlations, not facts.
So when I prompt it, it's triggering those patterns.
It's activating pathways, yeah. Finding the most statistically likely path forward based on those learned weights.
And it doesn't just spit out the whole answer at once, does it?
No, absolutely not. That's key. It's autoregressive.
Yeah.
It generates the response token by token.
Token by token.
It figures out the probabilities for the very next token, picks one, adds it to the sequence, and then does the whole calculation again for the next token based on everything produced so far. It literally cannot see the end of its own sentence when it starts.
Wow. Okay. It's just looking at the immediate next step.
Always. Which explains why it can sound so fluent. It's mimicking patterns it saw millions of times. But, and this is the big warning.
Let me guess. Don't mistake fluency for truth.
You got it. It cannot verify anything. It just produces what looks right statistically. Fluency is not accuracy.
Okay, so if it's all about statistics and patterns triggered by our input, then the prompt, it's not just a question, is it? It's more like programming the statistics.
That's a good way to think about it. Your prompt isn't neutral. It actively biases the probabilities. Every word, every token you use nudges the model's calculations.
So keywords aren't like search terms.
Not at all. Think of them as activating specific parts of the model's network. Like you say, regulatory, and it's like flipping a switch that brings all the legal and compliance-related patterns to the forefront.
And our sources pointed out something interesting here where you put those keywords matters a lot.
Oh, hugely. Positional encoding. Basically, words at the beginning of your prompt have more influence, more weight in guiding the whole generation.
So front load the important stuff.
Definitely. If you need a report on, say, financial risks, starting with analyze the key financial risks is way better than burying financial risks somewhere in the middle. It
Yeah.
sets the direction more strongly.
And we can use this idea for more than just keywords, right? Like giving the AI a personality.
Absolutely. Role attribution. Super effective. Tell it, act as a seasoned marketing strategist, or explain this like I'm 5. What you're doing is forcing the model to focus its attention on the token patterns associated with that persona or that level of simplicity. It changes the vocabulary, the sentence structure, everything. Much better results for specialized topics.
Okay, so if that's good prompting, what's the biggest mistake people make? The thing to just stop doing?
Probably the monolithic prompt. You see it all the time. People ask for everything in one go.
Yeah.
Define X, compare it to Y, give 3 examples, summarize the history, and write a conclusion. It's just too much.
Why is that bad?
Because the model gets overloaded. It tries to juggle all those instructions, loses focus, maybe skimps on one part, goes off on a tangent, the attention gets diluted, and the out quality tanks. Rushed, incomplete, unbalanced.
So the better way is?
Iterative prompting. Break it down. Small, focused steps.
Okay.
Ask it to define X first. Get the answer. Then, okay, now compare that definition to Y. Wait again. Then give me those 3 examples. You guide it step by step.
More control that way.
Way more control. It prevents that semantic drift where it kind of forgets what it was doing halfway through a long answer. You get more detail, more focus.
Right. Okay, that makes sense. Let's shift to the second T, then token capacity. You mentioned limits. We need to understand the currency here. What exactly is a token?
Okay, so a token is the model's basic unit for processing text. Crucially, it's not always a whole word.
Ah!
Simple words might be 1 token, like the or cat. But longer or less common words often get split, like unbelievable might become 2 tokens. Unbelievable. Punctuation can also be a token.
So complex language costs more tokens.
Generally, yes. Technical terms, jargon, they tend to consume more tokens.
And the context window is like our spending limit.
Exactly. It's the total number of tokens the model can remember or consider at any one time. And this includes both your input, your prompts, and the AI's output, its answers.
Even the big models have this limit.
Oh, yeah. GPT-4, GPT-4 Turbo, they have big windows like 8,000 or even 128,000 tokens, but it's still finite. And when you hit that limit, you get truncation risk.
The whiteboard analogy you mentioned?
Yeah, imagine writing on a whiteboard.
Mm.
When you run out of space on the right, you have to start erasing stuff from the left to keep writing. The model does the same. It forgets the beginning of the conversation to make room for the new stuff.
Which makes it seem like it has amnesia.
Exactly. Suddenly it doesn't remember what you asked it 5 minutes ago. That's why managing your tokens isn't just technical, it's strategic.
Okay, give us the practical tips. How do we save our token currency?
Tip 1, just be concise. Seriously, cut the fluff.
No. Good morning, AI. I hope you're well. Could you possibly...
Nope, wasted tokens. The model doesn't care about politeness. Phrases like, could you please do me a huge favor, might cost you 10, 15 tokens for 0 benefit. Just state the instruction.
Brutal efficiency. I like it. Tip 2.
Manage your input versus output ratio. Think about it. If you paste in a massive 10,000 token document and ask for a summary.
You've already used up a huge chunk of the context window.
Right. You might leave very little room for the actual summary it needs to generate.
Mm-hmm.
So the answer gets cut off halfway through. You need to budget tokens for the output too.
Smart. And the last tip ties back to positioning.
Yes, instruction decay. Or maybe call it instruction primacy at the end. Just like the beginning matters, the very end of your prompt has a strong immediate influence.
So critical instructions go last.
Put your absolute must-haves constraints like format the output as bullet points, limit the response to 200 words, do not mention topic Z right at the very end, reverse pyramid style.
Why?
It ensures that crucial constraint is fresh in the model's mind, right as it's about to start generating the response.
Yeah.
Less chance of it getting lost or ignored.
Okay, super practical. Now, the big one, hallucinations. Our sources called it confident generation of incorrect information. Not a bug, but an artifact.
An emergent artifact of how it works, yeah.
Yeah.
It happens when the model hits a point where the statistical path isn't clear from its training data. It doesn't know the answer.
But it has to generate something.
Its core function is to produce fluent, plausible-sounding text. So if it lacks the specific data, it essentially invents a plausible sequence to keep the fluency going. It fills the gap with something that looks right.
The example from the sources was pretty stark, asking about female judges in Abu Dhabi.
Oh, that was a classic. The prompt asked for the first 3 female judges of the Abu Dhabi Commercial Court.
And the AI.
It confidently generated 3 completely fictional names gave them precise appointment dates, even cited a non-existent law, Federal Law Number 17 of 2012, as justification.
Wow.
Looked totally real, perfect structure, legalistic language, but zero basis in reality. Pure syntactic truth built on semantic fiction, as the source put it.
Okay, that's scary. How do we fight that? How do we mitigate it?
There are controls. First, parameter settings. Specifically, you need to lower the temperature.
Temperature.
Yeah, controls randomness. High temperature means more creative, more varied, sometimes wilder output. Lowering it way down, like to 0.2 or 0.3, makes the model stick to only the highest probability, safest token choices. Less speculation.
So turn down the creativity knob.
Essentially, yes, for factual tasks. Second strategy, metacognitive prompts.
Meaning?
You give the AI instructions about its own thinking process, like only provide information you are at least 90% certain is factually correct. Or, if you are unsure about any part of the answer, explicitly state, I do not have verified information on X, instead of guessing.
Trying to make it admit uncertainty.
Exactly. And the third, and honestly most crucial habit.
Let me guess. Check its work.
Always. External verification. Treat everything it gives you as a draft that needs fact-checking. A good diagnostic trick, if something feels off, ask it directly. Can you provide the specific verifiable source for that claim?
And see if it hedges or makes up another source.
Precisely. If the answer changes or becomes vague, you know the first one was likely a hallucination.
Right, okay, that's controlling the output. But flipping it around, if we're reading something, how can we spot if it was AI generated? Are there tells?
Definitely. AI text often has structural signatures. 3 things to look for. First, low perplexity. It's too predictable. The word choices are incredibly safe, fluent, almost bland. There's no surprise, no unusual phrasing. It just flows. Maybe too smoothly.
Too easy to read, almost.
Kind of, yeah. Second, low burstiness.
Burstiness.
Human writing has rhythm changes. We write a long, complex sentence. There may be short, punchy one. We vary the cadence. AI output often lacks this burstiness. Sentence lengths tend to be very uniform. The rhythm very predictable and even. Again, too smooth.
Okay, predictable flow, even rhythm. What's the third?
Vocabulary, what we might call fluency artifacts, or just buzzword overload.
Mm.
Models tend to overuse statistically common but semantically weak words. Think leverage, streamline, synergy, impactful, pivotal, empower. Words that sound professional but don't carry much specific meaning or tension. The text feels polished but empty.
So too smooth, too many buzzwords.
Those are strong indicators.
Yeah, this has been incredibly clarifying. It feels like the takeaway is stop treating AI like magic. Understand its gears, the statistics, the tokens, and then design how you interact with it.
Exactly. Mastering prompting, managing tokens. Yeah. It's not a workaround. It's the core skill. You're working with its nature. Remember, the coherence we see is structural. It's good at patterns. But the flaws, the hallucinations, they're structural too. They're the flip side of that statistical generation.
So wrapping this up, what's the final thought for people trying to navigate this, both as creators using AI and as readers trying to discern what's real?
Well, it's kind of ironic, isn't it? Real human writing.
Mm-hmm.
It's often messy. It has imperfections. Awkward phrasing sometimes, sudden shifts in topic, maybe inconsistencies. That very messiness, the unevenness, the inefficiency that's often the signature of a real human mind at work.
So perfection is suspicious.
In a way, yes. If a piece of text is too polished, too perfectly structured, too relentlessly consistent in tone and rhythm, that flawless surface might be the biggest clue that there wasn't actually a human thinking behind those words. That consistency is the machine's tell.